Before I go to Hibernate transactions, let us spend some time on discussing normal transaction management in a managed environment and non-managed environment. What do I mean by managed environment? Managed environment means if your application is running in an application server, then server will be managing the life cycle. So that is called as managed environment. Or if your application is standalone application, which is not running in any server, we call as a non-managed. So suppose, let us understand, if your application is talking to one database, how will you handle transactions? And if your application is talking to more than one database, then how do you handle transactions, right? First, let us talk about your application talking to a single database. Generally, tell me, if you are using a single database in your application server, do you configure a data source? Yes. No one uses JDBC connections. No one uses something like driver manager.get connection. You will never use it. You will always get the connections by using data source.get connection. We use data source to get advantage of connection pooling, right? Okay. Let us assume if your application is talking to only one database, how do you start a transaction by using JDBC API? Connection.set auto commit false. By default, auto commit is true for JDBC. If you say connection.set auto commit false, it will start a transaction, right? Okay, no problem when your application is talking to a single database. Assume a scenario where your application is talking to more than one database. Then how are you going to handle the transactions? See, I am writing the databases. I am just drawing the diagrams. This is database 1 and this is database 2. Now my application wants to fire some queries on database 1 and some queries on database 2. Let's assume that in a transaction I want to fire 10 statements. 5 statements on database 1 and 5 statements on database 2. Transaction means what? A unit of work. Whether all of them should succeed or everything should roll back. Right? Now I am firing 5 on this and 5 on that. Assume that 5 queries which I fired on this database were successful. And one of the queries which I fired on this database failed. Now in this case, I have to roll back the transaction, right? So if your application, if your transaction is spanning over more than one database, that is called as distributed transaction. And the protocol which is used in distributed transaction is two-phase commit. Okay, let us discuss about what is two-phase commit and how the distribution transactions are handled, right? If you want to use distributed transactions in your application, you need to use a component called as transaction manager. You might be knowing about transaction manager in your J2E, but just reverse me very quickly. Transaction manager is implementation of JTS. JTS stands for service, Java Transaction Service. In JEE API, JTS is a sub-specification. Implementation of this JTS specification is transaction manager component, right? In JEE we have a lot of specification. Implementation of servlet specification is nothing but the servlet container. EJB specification implementation is EJB container. JTS implementation is transaction manager component, right? So transaction manager is part of JTS, right? Now, as JTS is a specification, every application server vendor will be having their own implementation of transaction manager. JBoss has their own implementation, WebLogic has their own implementation of transaction manager, WebSphere has their own implementation of transaction manager. Now, as an end user, if I want to interact with transaction manager, for me it should be exactly same, right? Working with JBoss transaction manager should be same as working with WebLogic transaction manager. So transaction manager should be abstracted from the end user, right? So we should not be able to directly interact with the transaction manager. So for this purpose there is another API called as JTA, Java Transaction API. It is also a specification as part of JE, right? So in JTA there is an interface called UserTransaction, Java x.transaction.UserTransaction interface. So the application servers will be having implementation of this interface. Definitely they will be implementing JTA specification. There will be one implementation of this user transaction, right? So whenever your application is starting, application server is starting, if your WebSphere is starting, what it will do? It will create an object of transaction manager. Transaction manager is started, not object. Transaction manager is a component. When application server is starting, transaction manager component is started, and also application server creates an object of user transaction. Actually user transaction is an interface. Application server will create an object of its implementation because it knows what is its implementation, and then it will register this user transaction object in JNDA, right? So if you want a user transaction object, what you do, you look up the JNDA and get the user transaction, right? What is the use of this user transaction implementation? As I told, transaction manager is abstracted from us. We cannot directly interact with the transaction manager. So if you want the transaction manager to start a transaction, you call user transaction object dot begin transaction, begin. If you call begin method on user transaction, that user transaction implementation knows how to interact with transaction manager. User transaction object knows how to interact with transaction manager. So it allows the transaction manager to start the transaction. So if your program wants to interact with transaction manager, it is through user transaction object, right? Okay. Now talking more about transaction manager implementation. Generally, if our application is having two databases, if you are interacting with two databases, generally you will be creating two data sources, one data source per database, right? Whenever you are creating a data source, application server will create a component called resource manager. So whenever you register a data source, automatically a resource manager also is created and it will be started. So two databases, you will be having two data sources, you will be configuring two data sources. Whenever your data source is started, resource manager component also starts. One resource manager per data source, right? So now assume that these are the two databases, database 1 and this is the database 2. Then this is resource manager 1 for the first database and this is the resource manager 2 for the second database. So every data source will be having one resource manager. And when you are creating a data source, there is an option. Generally, if you are using WebSphere or WebLogic, if you are creating a data source, there will be one option. Allow this data source to participate in global transactions. If you select that option, then this data source can participate in global transaction, right? As I told, when application server is starting, transaction manager will be automatically started, right? So if you configure this data source to participate in global transaction, this resource manager gets registered with transaction manager. This is the transaction manager. And if whenever you are creating the data source for this resource manager, you can configure this data source also can participate in global transaction. So this resource manager will be registered with transaction manager.
Suppose we have a structure where we are using more than one server for the load balancing purposes, like clustering.
Then these resource managers also will be clustered.
What about the transaction manager? Will there be one or many? Depending on the number of clusters, number of nodes in the cluster.
See, whenever you are clustering, there will be one main server
Right.
and which will be managing the load balancing,
Correct.
and then other cluster nodes.
Right.
So for each node there will be one transaction manager.
So in each node there will be.
Wait, for each node there will be one transaction manager. But for the main one there also there will be one transaction manager. It is the responsibility of cluster to manage within itself, right? So let us first talk about without cluster. Then once the concepts are clear, we'll go ahead with the next discussion. Okay. So one transaction manager for the whole server and one resource manager for each data source, right? Now, let's assume that you are querying queries, 5 queries on this database and 5 queries on this database. Now you want to start a global transaction, right? If you want to start a global transaction, what will you do? You need to look up the JNDI and get the user transaction object first. Then you will say user transaction dot begin, right? So that will ask the transaction manager to start a transaction, right? This transaction manager, what it will do? It will may ask the resource manager 1 to start a transaction and resource manager 2 to start a transaction. So whenever we say user transaction dot begin, transaction is started on 2 databases, right? 2 data sources, okay, to be very clear. Okay. Now, whenever you say commit or rollback on the transaction user transaction object, right? Transaction manager, what it will do is, it is a 2-phase commit, as I said. Whenever we say commit, whenever we try to commit, the transaction manager will ask each of the resource managers, shall I commit? By using the protocol, 2-phase commit protocol class. As I said, 5 queries on the first database are succeeded. So this will say yes, go and commit. Then it will ask the transaction manager will ask resource manager 2, shall I commit? This will say no, because one of the statement failed here, right? If at least one of the resource managers says no, the whole transaction will be rolled back, right? This is the 2-phase commit protocol which is used by transaction manager, right? Any doubts in this, first of all? Once you understand the concept of transaction managers and JTA, let us go to Hibernate and see how Hibernate will integrate with JTA or Hibernate will integrate with normal JDBC transactions. Okay, in these transactions, if we have to discuss, we need to discuss about all the ACID properties. Every transaction will have ACID properties, atomicity, consistency, isolation, durability. We are not going to talk about all those because it is not particular to database, it is a normal database concept, right? Okay. Now, I just go through this presentation. In a non-managed environment, means in a standalone application, the JDBC API is to mark the transaction boundaries. You need to begin transaction by calling set.commit false and call connection.commit, connection.rollback, right? But in a managed environment, you should use JTA. You should use user transaction object. That's what is shown here in this presentation. Programmatic transaction management in Hibernate application is exposed to the application developer via Hibernate transaction interface. We have an interface called r.hibernate.transaction which we are already using. Session.begin transaction was given there, right? So we use this interface to start the transaction, right? But we are not forced to use this interface for starting a transaction. What we can do is, in session, there is a method called connection, session.connection. it will give you the connection object which the session is using, right? Then you can say connection or set auto commit false, right? You need not start a transaction by using this Hibernate transaction interface. You can do that way also, but it is not good. It is not recommended, right? We should always go for r.hibernate.transaction, right? In a Java environment, in a managed environment, you should not use this transaction object. You can use it, but it is not recommended to use r.hibernate.transaction object. It is recommended to use JTA transaction object, means user transaction object, right? Let us see why and how it is possible. So just 2 points. In a standalone application, you have to use r.hibernate.transaction. In a managed environment, which is a J2E server, JE server, you have to use JTA transaction only, right? Let us see now. Next, proceed. What is the advantage if you are using r.hibernate.transaction? The advantage, the main benefit is tight integration of persistence context management, tight integration of this transaction object with persistence context management. A session is flushed automatically once you commit. We have written a lot of programs till now. Did we say session.flush explicitly anytime? No. I was telling, whenever I say session.save, query is not fired immediately. It is fired at the end of the transaction. Or I told an alternative. You can explicitly say session.flush, which will make the queries to be fired. Right? Till now we never said flush, session.flush. We directly committed the transaction. Right? So if I say transaction.commit, it is internally flushing the session, then committing the transaction. So if you are using this interface is tightly integrated with session, right? You need not flush the session automatically if you are using this r.hibernate.transaction. But suppose if you are using session.connection, getting a connection not set auto commit false, you can do like that also, as I said. If you are starting your own transaction without using this transaction object, you need to flush explicitly, right? So it is not recommended to start your own transaction. Always use this r.hibernate.transaction, right? Okay, next. And in idea third, in a managed environment, you have to use user transaction, right? One more thing. How do I start a transaction? Session.begin transaction. Now, it is returning me an object of transaction, right? To create an object, can we use factories? Session factory for creating sessions. If you have used Spring, bean factory for creating beans, right? So factories are for creating objects. Internally in Hibernate, there is a transaction factory. Whenever you ask for a transaction, session.begin transaction, internally Hibernate is using a transaction factory to create a transaction, right? By default, the transaction factory is JDBC transaction factory, right? Okay, let me show you that option quickly. I'll come back again. Yeah, see here, there is a property called as hibernate.transaction.factory_class, which is by default configured to JDBC transaction factory, right? Whenever we are saying session.begin transaction, that begin transaction method is internally using this object, JDBC transaction factory object, to create a transaction, right? Where did we configure this property? Did we configure this property in our hibernate.cfg.xml anytime? No. Tell me, what is the default configuration file for Hibernate? Hibernate.properties. If you go and see in Hibernate.properties, this is there by default. Right? Okay. Now, if you want to use JTA in your application, instead of using single database, you want to use more than one database, it is always better to use JTA transactions, right? If you want to use JTA transactions, there is a small configuration which you have to do. Just I'll show you that one first. Yes. This is the configuration. You need to configure what is the data source. Hibernate.connection.data source is equal to the JNDA name of your data source. Your application server is using a data source to get connections. You have to use it, right? And second one, Hibernate.transaction.factory and scope class. Earlier I told you it was JDBC transaction factory. Now it is JTA transaction factory. Now if you configure the factory class as this one, it will use this transaction factory to get transactions from JTA, right? And also the third one is transaction.manager_lookup class. How to talk to the transaction manager. Hibernate provides a separate implementation for each and every application server. This JBoss transaction manager lookup is for JBoss server. For WebLogic, there is WebLogic transaction manager. For WebSphere, there is WebSphere transaction manager. You have to configure these three. If you configure these three, then Hibernate will be using JTA transactions. This is all commented. By default, we are not using JTA. By default, we are using JDBC transactions. If you are using in JTA, if you want to use JTA, then you have to configure this either in Hibernate.properties or in CFD.xml. Right? So if you configure this, then Hibernate will switch from JDBC transactions to JTA transactions. Right? Any doubts? Now tell me, if I configure this and I call session.begin transaction, it has to create a transaction. Session.begin transaction has to create a transaction. Internally, I told you we will be using the transaction factory. What are we configured for this one? Now it is JTA transaction factory. It will use this transaction factory to get a JTA, to start a JTA transaction, right? So now you understood how to configure Hibernate to use JDBC transaction as well as JTA transaction, right? How do you switch back to JDBC transactions? You comment this and make the factory class as Hibernate.transaction or factory class as JDBC transaction factory, right? It will switch to JDBC transaction, right? So whenever you say session.begin transaction, you will get transaction object, but that transaction is JTA is internally using JTA transactions, right? Now one more thing is here, whenever you are using JTA, it is not recommended to use r.hibernate.transaction interface. It is always recommended to use Java x.transaction.userTransaction, right? You will get the reasons why. You can use this also. You can use this also. Okay, fine. But it is recommended to use this user transaction object. Any doubts? Okay, I'll proceed. I'll just show you one example, then I'll come back here. Now see how my Hibernate can use global transactions. Now see this code, user transaction. I am looking up inside the JNDI. I got the user transaction object, right? Now I want to fire queries on two databases. That means if there are two databases, how many session factories will be there? two session factories, right? Now see here, by using this, this is one factory and this is another factory object. By using two different factories, I am opening sessions. Session 1 on first database, session 2 on second database. Right. And this is a method which I am not showing you. This is a method which is using the session 1 and performing some operations, assume. And this is another method which is using session 2 performing some operations, right? Then I want these all operations to be treated as a single unit of work, right? So I am using user transaction at begin here, right? Global transaction started here. This method is interacting with first database, this method is interacting with second database. Then if I say session 1.flush, all the queries on first database will be fired. Session 2.flush, all the queries on second database will be fired now. Now the scenario is what? Some queries on second database will fail, right? What I am doing, I am saying user transaction commit. It allows the transaction manager to commit, but the transaction manager will decide whether to really commit or not. It will ask each of the resource managers and decide whether to commit or not, right? So here I am using user transaction object only for transactions. I am not using Hibernate transaction object, r.hibernate.transaction. I am not using it. I am using user transaction object. This is the way to use user transaction when you are using JTA. Let me go back again to here. Let us learn something about session. What is the scope of a session? Scope means what? Until what time that is actually available in the memory is called as scope, right? Now to understand about scope, let us try to understand how are we getting a session. Factory.open session, till now we have used factory.open session. Factory.open session will always open a new session, but I have a requirement where I want to get the existing session. Let me tell about the requirement first. See this, I am having a method, some method m and some method x and some method y. I have three methods. M is calling x and y both. Okay. Now in this method m, in all the three methods I am performing some operations on session, right? Now in this method m, at this line I will start a session, factory.open session, let's assume. It will give me a new session. I will do operations on that session, right? Then I am calling x. In x also I want a session. Then again if I say factory.open session, it will give me a new session. Here also if I want a session, it will give me a new session. But a new session for every method is not good, right? Now what I want is, for all the three methods I want the same session. One solution is, as I said, here I will be getting a session object. Session is equal to something. The session object I can pass to x and also y as a parameter, and make x and y to take parameters. Okay, but is it a good option to pass session object to the methods? No. So without passing, what I want is, I want the same session to be available in the same thread. Tell me, if some thread calls m, x and y also are executed in the same thread. As long as I am using the same thread, for the whole same thread, I should be able to get the same session, right? If I am using Hibernate, see, session factory dot get current session, then in the same thread I will be able to get the same session. So whenever I want a session, now I will not say factory.open session. I will say factory.get current session. Here also I will say factory.get current session. Here also I will say factory.get current session. Here also I will say factory.get current session. Now, how this get current session is working? Let us try to understand that first. As long as I am in the same thread, I should get the same session. For other thread, I should get a different session, right? I hope you know about a thread local object. You can bind any object to thread local. Thread local.set method is there. You can give a name and you can set any object. Okay, and thread local.get is there. You can give the name. It will return you the object with which you are bound to the thread local, right? So one thread local will be there for thread. You can use one thread local for thread, right? Now by using thread local, you will be able to set an object with a name, and also you will be able to get an object with a name, right? Now, whenever you say factory.get current session, in that get current session method, what it will do is it will check. I am calling for the first time. In that name I am calling get current session for the first time, right? So what it will do is check in the thread local for this current thread, is there any session object already bound? If no, for the first time if I am calling, there will be no session object. If not, it will create a new object of session, bind it to the thread local, then it will return the session object. So for the first time whenever I am calling factory.get current session, it will create a new session, bind it to thread local, then return the session, right? Here again in X, I am calling in the same thread again, I am calling factory.get current session. Now again it will check, is there any session object bound to thread local? Now it is there, right? It will return the same session here. Here also it will return the same session, right? So if you want a same session for a thread, then what you can do is you can use factory.get current session instead of using factory.open session, right? Any doubts? Okay. Now this get current session method was not present before Hibernate 3.0.1 version. It was first introduced in Hibernate 3.0.1. Now we are using Hibernate 3.6.6 version, right? So this was introduced only with 3.0.1. Okay. Okay. Before understanding about it, tell me, whenever I am saying session.factory.get current session, where is the session object bound to? Session.factory.get current session, if I say for first time, it's creating new session object, it's binding it to thread local, or we can say on the top, it is binding it to the current thread, right? So here in this case, session is bound to current thread, right? So what is the life cycle of the session now? What is the scope of the session? Thread. If the thread is terminated, session also will be closed automatically, right? But by default, session will not be closed automatically. What you have to do is, you have to close session by default with default settings. Now what I want is, if the current thread is gone, you are binding the session to thread, right? If you want session also to be closed automatically, there is a configuration which I will show you right now. But just understand, session is bound to thread. This is in case of standalone applications. Standalone application means applications which are not deployed on a server, right? But in managed environments, means in an application server, if you are running, we will be using JTA transactions, right? So in a managed environment, factory.getCurrent session, whenever we call, the session object will not be bound to thread. It will be bound to JTA transaction object. Right? In a non-managed environment, it will be bound to thread. In a managed environment, it will be bound. If you have configured Hibernate to use JTA, then it will be bound to JTA transaction. Right? So now, what is the scope of a session when you are using JTA transactions? JTA transaction. If you commit the transaction, session also should be automatically. So we say that in managed environment where you are using JTA, session is scoped to JTA transaction. In non-managed environment where you are not using JTA, session is scoped to current thread. Right? Okay. Once you understand that, session factory.getCurrent session was introduced in 3.0.1, right? But when it was just introduced, it was working only with JTA transactions. It was not working in standalone applications in that version, right? So whenever you say session factory.getCurrent session in this version, it will always try to bind the session to JTA transaction. But if you are not using JTA, this method will throw a exception. But from Hibernate 3.1 version, this is made as pluggable. The scope of session can be pluggable. We can configure whether the session should be scoped to JTA transaction or a thread through configuration, right? So for plugging in, there is a parameter. Don't forget about it. See this one. There is a parameter called Hibernate.current_session_context_class. If you keep the value of this property as thread, the value of this property you can configure in cfg.xml file. If you configure the value of this property as thread, then your session will be bound to thread, right? If you keep the value of this property as JTA, then your session will be scoped to JTA transaction. From 3.1 version of Hibernate, it is made pluggable, and we can plug it to either to thread or JTA by this parameter, right? Any notes? Okay. How does this work? Okay. Now there is an interface called r.hibernate.context.current_session_context, and there are 3 implementations which are already given by Hibernate. These are the 3 implementations: JTA session context, thread local session context, managed session context. Okay, these are the 3 implementations, right? Whenever you are saying Hibernate.getCurrent session, it has to bind the session to either JTA transaction or thread. It will be internally using these classes. If I configure the value of this parameter as thread, okay, it will be internally using this thread local session context for managing the scope of the session. If I configure the value as JTA, it will be using JTA session context internally for managing the scope of. And there is a third value also for this parameter, manage. Manage means you can write your own way of managing the transaction, right? Coming to this example, tell me how can I modify this code so that I need not flush the sessions, I need not pass a session object here to these methods. Yes, here we are using open session, which is not good. If I say get current session, here to start a new session. In this method's concurrent option, I can again say get current session. So I need not pass session object to each method, right? And now, if I am using, if I am binding my session to JTA transaction, do I need to say session 1 dot flush, session 2 dot flush? By default, we need to flush. Transaction dot commit will not commit. If you don't want to flush explicitly, and if the flush should automatically happen, flushing of the session should automatically happen, and you need not close the sessions also. If I commit a JDBC transaction itself is closed. Session was bound to transaction. Transaction itself is closed now. Is it required that session should be there? So whenever you commit a transaction, you want the session to be automatically closed. So if you want that, these are the ones. Hibernate transaction not flush before completion means before the transaction is completed, flush it. And also Hibernate transaction not auto close session, close the session automatically, right? So these have to be enabled. If you want the session to be flushed before committing and session to be closed after committing, by default these are not enabled. Any doubts? Okay. Next thing, generally tell me if there are two databases in my application, how many factories have to be created? Two factories, one per database, right? How many times should we create a factory object? Whenever I require a session, do I need to create a factory? No, I am not talking about sessions. Factories, how many factories? When do we need to create a factory? Only for one time we should create, because creation of factory is very costly. It takes a lot of time. So we should not create factories more than once. Generally we have to create only once. Now, if I am writing a web application which will be running in an application server, where do I need where should I write the code for creating session factory? That should be executed when the application is started, right? But where should I write the code if I am writing a web application? You can write a listener. If you are using servlets, servlet listener is there, context loader listener is there, you can write it inside. Okay. But instead of it, what we can do is we can configure a parameter called hibernate.session_factory_name. You can give your own name, whatever name you want. If you configure this property and if you deploy this inside an application server, okay, then what will happen is application server will automatically create a session factory object, register inside the JNDA with this name, right? Remember, I am saying about application server, not Tomcat. Is it an application server? No. So in Tomcat it will not work. In application server which are supporting EJB specification, application server means they should support EJB. They should be having EJB control. In that application server, only this will work. What the application server will be doing is, it will see, it automatically scan if the cfg.xml is present inside the build path or class path. If it finds this property, then application server will automatically create an object of session factory, bound it inside the JNDA with that name. Right? This is how to create a session factory bound on JNDA. Hibernate.session_factory. Yeah, if you create a jar file and keep it inside this application server, automatically right? That's about it. We already talked about this. Any doubts till now? The next thing which we will discuss in State Transaction is how to control concurrent access to the database. Now in our application there can be lot of concurrent transactions. More than one transaction might be operating on same set of data, right? So a transaction should be having ACID properties, right? Atomicity, consistency, isolation. I want to talk about isolation. I want each of the transactions to be isolated from other transactions which are going on concurrently. Means each transaction should feel that it is the only one which is acting on the data, right? Each transaction should be isolated from the other transactions which are concurrently running. How does Hibernate handle that isolations? By using various strategies. There are two strategies how Hibernate will control this concurrent access. One is by optimistic strategy and one is by pessimistic strategy. Optimistic concurrency control and pessimistic concurrency control strategy. There are two strategies which Hibernate is using, right? Let us discuss first what do I mean by optimistic and what do I mean by pessimistic strategy. Right? Let us see. Generally isolation can be implemented by taking a locks on database rows, right? Okay, let us see first how it happens. Forget about Hibernate for some time. Let us talk about the normal JDBC concepts. When two JDBC transactions are happening concurrently, there is a possibility of lot of problems to occur. Means one transaction might be using stale data, might be working on some stale data, might be working on some data which is already modified by concurrently running transactions. There are some problems which can occur when transactions are going on concurrently, right? We will not discuss about those problems because they are not particular to Hibernate with normal database concepts. I'll just list down the issues. One of the issue is last update issue, dirty read issue, unrepeatable read, and also phantom read. These are the various isolation issues, right? Means there are various problems. These are the various problems, right? Now in JDBC, in normal database level only, there are some isolation levels. There are 4 isolation levels by default. Each isolation level will avoid some problems. These are the 4 problems I told, right? Last update, dirty read, unrepeatable read, phantom read, and there are many other problems also. These are the important ones which I listed. And in if you ask a database administrator, he'll talk about isolation levels. You can configure your database to be at a particular isolation level. The isolation levels are read uncommitted isolation level. This isolation level will avoid some of the concurrent problems, concurrent access problems, and some are still present. And again, read committed isolation, repeatable read isolation, serializable isolation. Each isolation level can be configured at database level. Okay. Each isolation level will avoid some problems and will still have the problems, right? Tell me, basically, if these isolation levels are not being configured at all, to avoid concurrent access, what we need to do? We need to take a lock on the database row, database table row. But if whenever I fetch some data, if I take a lock, then will it affect performance? So taking all locks is also not good. So we need to decide actually when lock has to be actually taken, when lock should not be taken. So these isolation levels tell about when lock has to be taken or not, right? These isolation levels have to be configured. Now we are not going to talk about isolation levels also, but because it is not specific to Hibernate, it's a database concept. If you ask your database administrator, according to your application, he can suggest you what is the best isolation level for your application. But among all the isolation levels, read committed isolation level is preferred by many of us. It will avoid a lot of problems, right? And it will make sure that the lock time of the database row also minimal, right? Now we are now in Hibernate, what we need to understand is how to configure isolation level. That's it. Now see, if you want to configure isolation level in Hibernate, this is the parameter which you have to give, and the value 2 here, right? See, if you want to configure Hibernate to use read uncommitted isolation level, the value is 1 you have to give. 2 for read committed, 4 for repeatable read isolation level, 8 for serializable, right? So just you need to know about these options. If you want to configure these isolation levels, you can contact your database administrator and ask what is the isolation level appropriate for our application. We'll tell the name, accordingly we configure these values, right? Okay, any doubts? Okay, coming to optimistic strategy, pessimistic strategy. Yeah, tell me. Everything in cfg.xml or hibernate.properties. Whatever I told you till now, the properties, JDBC transaction factory class, everything, we have to configure either in cfg.xml, hibernate.cfg.xml, or in hibernate.properties. Okay, let us see this example to discuss about concurrency strategies which are used by Hibernate. There are two conversations which are starting concurrently, parallelly. Conversation A fired a select query and got some data, D1. And conversation B also fired same select query which has got the same set of data. Now, in conversation A, the user A made some updates on the same data and then committed it here, right? Conversation B is taking some more time, the second user is taking some more time. He also made some updates on the same data D1 which he selected here and then firing update. After first conversation A has been completed, then conversation B completed. Now tell me, database will be having which values, latest values? Conversation A or conversation B? Conversation B. Conversation B, because this has been committed last. So the changes made by the first user are lost, right? Let us take a scenario. You are making a reservation, flight reservation. You have selected one of the seat, and before you, two users have selected a seat. Same seat they have selected on same flight, and you require some time for processing your credit card, right? First user processes his credit card first. When both of you searched, both of you saw the same seat as empty. Then you booked it. First user gave the credit card details very fastly. He reserved it. Then after some time, user 2 also gives credit card details and then commits it again. So what will happen in this scenario? The first user will lose his seat. In their database, it will say only second user has booked the seat, right? This should not be allowed, right? So there are various strategies last commit wins. If I use last commit wins, what will happen in this scenario?
Whoever did it last.
Yeah. So the second person will get the seat result. First person, even though he got the confirmation, finally when he goes for the flight boarding, he'll say this is not your seat. Okay? So that is not good. First commit wins. This seems to be good. Right? What should happen in this strategy? A will get committed, and whenever B tries to commit, he should get an exception saying you are working on a stale data. Right? This is a good strategy, right? So we in Hibernate we always prefer this first commit wins. Now, how does Hibernate make sure that this will happen? By using versioning. Now, if you are using versioning, you are acting like an optimist. Means you don't want to actually take a lock whenever you fire a query. You are firing a select query. You are searching for all the seats available. You fire a select query. Right? Two concurrent users are firing the same query now. Get seats which are available. It displays same seats to two users. When he is firing a select query, he is not asking to take a lock, right? So two users will get the same data now. Okay. Now in case of Hibernate, what it will do is it is using a concept called versioning. What we need to do is in your entities you need to create a variable called version of type int, and you need to write a tag inside the class called version tag. You need to give a separate column for it. So in each of your table there will be a column called version. Now let us see how to use this version with an example. Now this is my table. It is having a version a column called version. And inside this there will be some primary key, say this is the ID, and some other columns also. Now there are a lot of rows inside this table, right? Whenever an insert is made inside the table through session.save, whenever Hibernate inserts, by default for the first time whenever you insert a row, the version of that row will be 0. Remember, you will never set version programmatically. Version will be set by Hibernate only. You should not set it. Okay, whenever you say session.save, it can insert a row. There are various strategies. One strategy is to have this column physically. One strategy. This is the first strategy which I am discussing. There should be a column in the database called version. So for the first time whenever I am inserting, the value will be 0. Okay. Now assume that there is a row. There is one row with primary key, say 1, 2, 3. 1, 2, 3 is the primary key of this row. Now these are the two transactions. Concurrent. These are two users. This user is having a transaction 1, transaction 2. This is transaction 1, and both of them are in two separate transactions. Now these two users fire the same query which will retrieve the same row with ID 1, 2, 3, right? Now these are the objects. Here this object will be having a value for version as 0, and when they fire select query, this also will be having 0, right? Now what will happen? Both of them got the same data. This user will change some data in this object. We change some data in this object, and let's assume transaction 1 is committed first. Okay. Whenever an update is happening on the table through Hibernate, what it will do is it will increment the version automatically. Now it will be 1, right? Whenever second transaction also will modify same object and tries to commit it, but when it is trying to commit, Hibernate will compare the version present in the object with the version in the database. If both are not same, what is the meaning? The user is working on a stale data, right? So Hibernate will throw an exception, right? So whenever Hibernate is firing a query, it will compare the versions in the object with the version in the database. If both are matching, then only update will occur. Otherwise, Hibernate will throw an exception saying you are working on a stale data. Okay? Any doubts? Okay. So now in this case, whenever you are firing the select query, are you taking a lock on this row? No. Taking a lock will always degrade the performance, right? So you are not taking a lock whenever you are firing a select query. That means that you are optimistic and you feel that nothing will happen, right? If something will happen, Hibernate is anyway throwing the exception, right? So this is called as optimistic concurrency control strategy, right? You can configure optimistic concurrency control strategy by using versioning. This is one option, or another option is, instead of keeping a variable of type version, you can create a variable called of type date, and also you can use a tag called timestamp, and there should be a separate column for this timestamp also. You can use either one. If you are using timestamp, the column will be updated with the latest modification time, right? Right? So in your application, if there is a requirement which says you need the latest modification, last updated time, then you can use timestamp. Or if in your application, if you have a requirement which says that I want to know how many times this row has been updated, then it is better to use versioning. Version is incremented every time you update, right? So according to your application, you can choose either versioning or timestamp for optimistic concurrency control. Okay? Any doubts? Next, what the Hibernate will be doing automatically, as I said, it will be comparing the versions. Now, in the previous strategy, we require a separate column called version for each and every table, which may sometimes seem to be not good, because in each and every table, if I need to have a column called version, I don't want, right? So the other way is to use, don't use version or timestamp. Use, for this item you can use optimistic clock is equals to all. What this will do is, if you configure like this, what this will say is, whenever an update is made on this item, right, Hibernate will try to compare the values, all the values for all the columns in the table with the current values in the right. In Hibernate, we will be having the old object. Whenever it has fetched, it has got the old object, right? It will compare the values in the old object with the values in the table. If all of them are same, that means that no one has modified it, right? Then only it will allow. Otherwise, it will throw an, right? But is this good? No, because if my table is having 100 columns, big table, 100 columns are there. In this update query, in where condition, 100 columns have to be compared with old values, which may not be good, right? If your table is very small, you can use this, right? If the table is very big and if you don't want to use a separate column for version or timestamp, you can use it. Accordingly, you can selectively use either this one or same version of timestamp. But most of the times we will prefer versioning or timestamp. What is it again? Optimistic lock. There is nothing like optimistic lock. Lock is not actually taken on the database. When you are saying optimistic, when you are using optimistic strategy, lock is never taken on database. Just whenever it is firing update query, it will compare the old data with the table data. That's it. Lock is never taken when you are using optimistic strategy. Okay, pessimistic. You are so pessimistic that you feel that something wrong will happen in your application. You don't want to take a chance. Like in the previous application, in the previous example, I told if 2% reserve the same seat and the last one succeeds, it will be a problem, right? If you don't want to take a lock, if you don't want to take a chance, then you can be pessimistic and you can ask for a lock on the database row. Of course, if you are being pessimistic, that comes at a price. Performance will be degraded if you are taking locks, right? If you go to Indian Rail site and make a reservation, if you try to make a reservation, you select a seat and it will take some time for your credit card to get processed. You will take some time for entering, right? Now, once you have selected, will that seat be locked for some time? Yes, for 5 minutes or so, they are locking it. Whenever some other search, it will not show that seat, right? In some of the bus sites also, if you go to red bus, I saw that. Or if I go to RTC site, it was there actually. KSRTC or FSRTC, I saw it. They are locking it for some 5 minutes or 10 minutes. Why? Because let us assume that they are using optimistic strategy. 2 users try to book a seat number 10, right? It will show that seat number 10 is available for both users when they search. User 1 will block it and go for credit card processing, right? Let's say user 1 commits, use a credit card, it is very fastly and he succeeds, right? When you are optimistic, you didn't take a lock on that row, right? So user 1 will succeed. Then when user 2 is submitting credit card details, what will happen? First will take you to the bank site. You will give all the credit card details there. Then you will come back to the application again. But when the application is here, the seat is already booked. When you are using optimistic strategy, you didn't take a lock. It's already booked. Now it will throw an exception saying that it's already booked. But now what the application has to do? Already the amount has been deducted from your account. Now it has to give it back to your account, right? If this fails, so they don't want to take a chance, so that's why they lock it for some specified duration. After that, it will release that state, right? Any doubts? You can be pessimistic. When you are pessimistic, what you do is, whenever you are firing a query, you say, I want a lock on this row, right? See how to get a lock. Session.get, we have already seen session dot. Okay, we have already seen session.get, right? Session.get, what it will do, it will try to fire a select query on the table. Just I'll show you quickly. If I am saying session.get, there is another option. I can specify comma. There are various overloaded session.get methods. See, there is a method which is asking for lock mode, right? You can specify a lock mode. So whenever it gets an object to the memory, whenever it fires a query, it will ask the lock on the database. So a row on the database is locked. if any other user is trying to get the same row, they will have to wait until the lock is released, right? So by using session.get, by using a lock mode, you are getting a lock. So in this case you are using pessimistic, you are being pessimistic and you are taking a lock, right? When you say session.create query also, this is a query demo. When you say session.create query also, on this query object dot set lock mode, right? There is a method called set lock mode where you can set the lock mode. So all the rows written by this query will be locked, right? So you can use pessimistic locking to lock, which is not good always, but sometimes if you prefer you can use it. That's up to you, right? Hibernate provides both way of concurrency control, right? Any doubts? And there are various lock modes which you can see from the API. What is the meaning of each of the lock modes?